Good morning, students. I'm very sorry, extremely sorry, because I didn't record the morning's lecture. So, but it's a very important lecture because it's the beginning lecture of second year and also optics. So I'm recording it again and I'm doing it. I'm giving the summary of what I discussed in the morning. Okay, so those who attended, they'll understand. Those who are not attended and watching this one for the first time, okay, still they can understand because I'll explain in detail also. Okay, little bit may not be like in the morning, but I'll explain. Okay, so I'm very sorry for not recording in the morning. Okay, so let us start today's session. So this is the second year syllabus. This is the second year syllabus where in second year we have 4 units. One is called optics, electricity and magnetism. Next one waves, and then modern physics. So out of all these 4 units, the second unit is very important. It's called as electricity and magnetism, from which approximately 10 questions will come. Okay, if you assume 30 questions for JEE mains, okay, so out of 30 questions for first year, around 12 to 14 will come, and the second year part 18 to 16 questions will come. Okay, so and within that 18 to 16 questions, around 8 to 10 questions will come from electricity and magnetism, and from optics 3 or 4, and waves 1 or 2, and modern physics 4 to 5. Okay, so this is the second year, and second year is very easy compared to first year. Okay, students. So this is a very important. Okay, so next slide is this one, where so this is called optics. So in that I'm starting first topic, that's called as optics. Okay, so first unit optics. So what is meant by optics? It's nothing but study of light. Okay, and we know light has dual nature. That means it behaves both as a ray as well as a wave. Okay, so in order to explain certain phenomena like reflection and refraction, we consider light as a ray. Okay, and the study of these two things is called as ray optics. Okay, and in order to explain certain another phenomena like interference, diffraction, and polarization, we consider light as a wave. Okay, wave means like this. It will be in the form of like this, which will have some length, which we call it as wavelength, lambda, and it will have certain frequency and also velocity. Okay, whereas rays is a collection of particles. Okay, it's a straight line. So now study of these 3 topics is called as wave optics. Okay, because light has dual, so we have 2 topics. One is called ray optics, another one is called as wave optics. So what is meant by ray optics? It's nothing but the light is treated as a ray and is valid only when the wavelength of light is less than the size of the object. So what does it mean? The wavelength of light is less than the size of the object. It means that when the light falls on certain object, okay, if the object size is much greater than the wavelength of the light. We know the wavelength of light is 3800 to 7600 angstroms. So it's very less. Okay, and if the object size is greater than that, then in that case we consider light as a ray, and the study of that topics is called as ray optics. Okay, like for example, here we can say plane mirror. So there is a plane mirror here. Now if the light falls on this, now plane mirror means generally 5 centimeters or 10 centimeters, or 1 centimeter also is more than what you call 3800 angstroms, correct or not? So therefore here, since the wavelength is less than the size of the object, we consider light to be as a ray. Okay, and then here, suppose let's say spherical mirror, concave mirror or convex mirror also. Generally sizes of the mirrors will be much greater than the size of the wavelength size of the light. So therefore here we consider light to be a ray, and the study of these 2 topics is called as ray optics. And what is meant by wave optics? Here light is treated as a wave and is valid only if the wavelength of light is greater than the size of the object. Okay, like to explain certain phenomena like interference, diffraction, polarization. Interference means there is a particular experiment where there will be a slit or hole. Okay, and the light will be incident on this hole, and the size of this hole is very less, very minute, small size, maybe needle end like that. Okay, so since that size of the hole is much less than the wavelength of the light, here light is considered as a wave, or here the wavelength of light is greater than the size of the object. That means size of the object is very less. Okay, in terms of nanometers like that. Okay, so therefore the study of these 3 phenomena, that is interference, diffraction, polarization, is called as wave optics. Okay, students. So now before going to further topics, let us first discuss about properties of light. Okay. So what are the properties of light? Number one, the light is nothing but a form of energy, okay, which propagates in the form of electromagnetic wave. Electromagnetic wave means it will have electric field wave and magnetic field wave. Okay, students. So the propagation of light in this format is called, the propagation of waves in this format is called as light. Okay, it will have some energy. Okay, and second property, doesn't require medium for propagation, unlike sound. Sound requires a medium for propagation. Next one, velocity of light. What is the velocity of light? Velocity of light is equal to 3 into 10 power 8 meters per second in air or vacuum, and it varies from medium to medium. In another medium, it will have some other value. Okay, like for example, in glass, it may have 2 into 10 power 8 meters per second, or in water, it will have some other value. And wavelength of light is 3,800 to 7,600 angstroms. Is the visible wavelength. Okay, less than 3,800, it's called as infrared region, and more than 7,600 angstroms, that region is called as ultraviolet region. Okay, next, V equal to F lambda. Okay, sorry, I told wrong. That is less than 3,800 angstroms is ultraviolet region, and more than 7,600 is infrared region. Okay, and this is a wavelength for visible light. Okay, and we know the relation between these three quantities, V equal to F lambda, where F is called as frequency. This is a very, very important quantity because it doesn't change when the light goes from one medium to another medium. It is the only one quantity which doesn't change, whereas velocity and wavelength will change when the light goes from one medium to another medium. Okay, and you may ask why does the frequency doesn't change? This we'll discuss in waves, but just I'll give you that why it doesn't change. Okay, in just I'll give the frequency doesn't change because the frequency is entirely dependent on the source of the light. Okay, suppose let's say you have taken one lamp. Okay, suppose sodium lamp or like that, then it will have certain frequency, let's say 100 hertz. Okay, so now when this light goes from medium 1 to medium 2, when it light enters into medium 2 also, the frequency remains 100 hertz only. Okay, because frequency won't change. Why? Because you are not changed the source of the light, so therefore it remains same. Okay, and next, sixth property is velocity of light is more in rarer medium than in denser medium. What is rarer medium and denser medium? We'll discuss afterwards. Okay, and then monochromatic light. What is meant by monochromatic light? Light of single wavelengths. Light of single wavelength is called as monochromatic light. Okay, so this is very, very important, students, these properties. And then afterwards we'll start with our chapter that's called as ray optics. It's called as ray optics. Okay, this is a specific chapter. I don't know the number of the chapter name, which number it has, but there is a chapter in your textbook. Please purchase the textbooks. Okay, second year textbooks. Okay, so ray optics. So this and there is one more chapter that is called as wave optics or physical optics. Okay, so this ray optics will study under three headings. One is called reflection, refraction, and optical instruments. And in case of reflection, again, we'll discuss reflection in two headings. One is called as plane mirror, reflection at plane surface, and one is called reflection at spherical surface. Reflection at plane surface is also called as plane mirrors, and this one is concave mirror or convex mirror. And refraction at plane surface and spherical surface. Refraction at plane surface means studying refraction phenomena in prism or slabs. Okay, and refraction at spherical surface means lens. Okay. And then last one is called as optical instruments, like simple microscope, compound microscope, astronomical telescope, telescopes, terrestrial telescope, like that. Okay, so this is the overall view of this chapter. We'll go one by one. First with plane surface, that is plane mirrors will cover, then spherical mirrors will cover, then prism, slabs, and then lens, and then last optical instruments. Okay, so if you ask me what is the most important topic from which the question will come, the three questions or two questions or one question, okay, is a lens is the first and foremost priority. From this lens, they'll use definitely one question or two questions. And then next priority is prism or slabs. And then next one is maybe mirrors, either concave or convex or plane or optical instruments. Optical instruments is also very important. Nowadays, they're asking frequently in optical instruments. Okay, student? So this is the overview of this entire chapter that's called as ray optics. Okay, and then so let us begin with the first topic that's called as reflection. Okay, so what is meant by reflection? If the light gets reflected back into the same medium, then it's called as reflection. Whereas if the light goes from one medium to another medium by bending, that's called as refraction. Okay, so in refraction, there will be two media. Okay, one medium and another medium. Suppose air medium and water medium, or air medium and glass medium. Whereas in reflection, it is only one medium. You'll have a plane mirror, and then light will be incident on the plane mirror, and it will get reflected back into the same medium, air medium. Okay. So now in this reflection, you must have studied in your lower classes the first law that's called as law of reflection. Okay. So now the more fundamental to law of reflection, there are two more laws. One is called as law of rectilinear propagation of light and law of optical reversibility. So what is meant by law of rectilinear propagation of light? That is nothing but if the light ray travels, light ray will always travel in a straight line. That's called as the law of rectilinear propagation of light. Okay, and when the light ray travels in a straight line, and when two light rays intersect, also there is no problem. They just go upwards as it is, like a straight line. Okay, whereas in case of electric waves or magnetic field waves, okay, it is not like that. You must have studied in your lower classes where the magnetic lines of force won't intersect. Okay, they won't intersect at all. But here light waves can intersect, or light rays can intersect, and after intersection, they just go normally only, okay, in the form of straight line as they were traveling before. Okay, and then next law is called as law of optical reversibility. Okay, where in this law it states that the object and image can be reversible. Suppose let's say we take a convex lens, and if you place an object in front of lens, then there will be an image. Okay, now suppose here image is formed here. Okay, this is the object, this is the image. Okay, now in place of image, okay, at the position of image, if you place an object, if you place the same object here, then image will be formed where object was placed in the first case. So that means these two can be interchangeable, okay, irreversible, reversible. Okay, so that's why it's called as law of optical reversibility. Law of optical reversibility. Okay, and then comes the law of reflection that you already know, where the law of reflection states that the angle of incidence is always equal to angle of reflection, and the incident ray, reflected ray, and the normal will always lie in the same plane, and they'll meet at one point. Okay, that's a law, basic law, that's called as law of reflection. Okay, so now before going to the actual topics, okay, we need to learn certain basic fundamentals. We need to learn certain basic fundamentals, okay, or basic definitions. Okay, those are called as object and image. What is meant by object and what is meant by image? Okay, even though you may be familiar with these terms, but you should know clearly the distinction between all these terms. Specifically, what is real object, what is virtual object, what is real image, and what is virtual image. You should know specifically what is the difference between all these terms. Okay, students. So before going to learn these terms, first of all, you should know two things. One is called as incident ray, one is called as reflected ray. Okay, so what is meant by incident ray? For example, suppose let us say here we take this as a plane mirror. This is, let's say, plane mirror. Okay, so now on this mirror, suppose if light is incident like this. Okay, so then this is called as incident ray, and then the light will get reflected. This is called as reflected ray. Only the arrow makes the difference between incident ray and reflected ray. Okay, if the arrow is towards mirror, that's called incident ray. If the arrow is away from the mirror, that's called as reflected ray. So now our definition of object and image is entirely dependent on these two terms, incident ray and reflected ray. So let's define first object. What is meant by object is defined only with incident rays. So whenever we say object, immediately this term incident rays only should come. And what is meant by image, it is always defined with reflected rays. That means whenever you say image, the term reflected ray should come. Okay, you should not say in the definition of object reflected rays. Suppose if I ask you what is the definition of object, real object, you should not say real object is a point where reflected rays, the term itself should not come. Have you understood, students? So this is a very, very important definition. These are very, very important definitions. So you should learn it thoroughly. You should write down in your notes first of all, and then learn it properly. Okay, so what is meant by objects? Object is nothing but object is always defined with incident rays, and image is always defined with respect to reflected rays. Okay, so now what is meant by real objects? So this object is of two types. One is real object and one is virtual object. Okay, so what is meant by real objects? Real object is a point where incident rays. Okay, so as I told you before, whether the object is real or virtual, it should always be defined in terms of incident rays. See here, incident rays. So therefore, you should always look for incident rays. Or in a definition, suppose let's say there is a term incident ray, then immediately you should understand that that definition belongs to objects. It can be either real object or virtual object. That is different. Okay. But immediately in the definition, if the term incident ray means, if the term incident ray is there, means it means that that definition belongs to objects. Okay. So what is meant by real objects? So real object is a point where from which incident rays, and incident rays actually, why actually? Because it's real. Real means, you know, it's actually it is happening. Virtual means appears to. Okay. So it's a point from which incident rays actually diverge. So if the incident rays actually diverge from a point, that is called as real object. It's very, very important. And what is meant by virtual objects, friends? Virtual object is also a point at which incident rays. Right now, see here, this is a plane mirror. Now these two are incident rays. Correct or not? See the direction of arrows. If the arrows are towards the mirror, that's called as incident rays. Okay. So if the incident rays fall like this, okay, then is a point where incident rays appear to converge. Now after the rays come here, what will happen is these rays, after falling on the plane mirror, actually here, when the ray falls like this, like this, like this, it will get reflected. Okay. But we are not interested in reflected rays. We are interested only in incident rays. Why? Because we are discussing only objects. So therefore, now if you extend these rays, these incident rays, if you extend these incident rays, what will happen, friends? They'll meet at one point. But they appear to meet at one point. They're not actually meeting. Why? Because this ray, when it is incident here, afterwards it will get reflected like this. This we are extending. It's not happening there. Okay, students. So we are extending it. Okay. So it appears to converge. So therefore, virtual object is a point at which incident rays appear to converge. Appear. It's only appearing. Whereas here real object is actually diverging. It's a point from which the incident rays actually diverge. They actually get diverged. Okay. And then real image and virtual image. Real image, whether the image is real or virtual, it should always be defined in terms of reflected rays. Okay, student. So real image is a point where, so when we say image means reflected rays. So first of all, for the reflected rays to be there should be incident rays. So for example, let's say these are the incident rays, for example. Okay, student. So when these incident rays are incident on this mirror, what will happen? They'll get reflected like this. These are reflected rays. Okay. Now you can forget about these rays. These are incident rays. Right now we are not discussing about incident rays. We are discussing only what we call incident reflected rays. Okay. So now when these reflected rays actually converging, see here, they're actually converging or not, then it is called as real image. So it is a point where reflected rays actually converge. Okay. They're actually converging. Okay. And the opposite, virtual image. So this is also image. So that means in this definition, it should have reflected rays. Okay, appear to diverge. So it's a point where reflected rays appear to diverge. Okay, student. So for example, I'll explain here. So suppose let's say this is a, suppose let us say here is an object is there. So first of all, incident rays will start like this. These are the rays, incident rays. Why? Because arrows are towards the mirror. Okay, but are we interested in the incident rays, students? No, because we want reflected rays. So let us forget these rays. Okay, so now these rays are the reflected rays, because for the reflected rays there should be incident rays. That's why I have drawn those incident rays. Now these are the reflected rays. Now these reflected rays, actually these reflected rays are going like this. Correct or not, students? So now what is the definition of virtual image? Is a point where reflected rays appear to diverge. Now if you can extend them back, they'll meet at one point. If you can extend them back, they'll meet at one point. That point is called as virtual image. Why? Because it is a point at which the reflected rays appear to diverge. They are not actually diverging here. We have extended. That's why we are drawn as dotted lines. These are dotted lines. We have extended. So therefore, these are reflected rays which are appearing to diverge from this point. So therefore, it's called as virtual image. Okay, students. So this is very, very important. So now actually these are the rays, reflected rays, which will form only when there is an object which is like this. Correct or not, students? When there is an object here, real object, then only first incident rays will be there, then only reflected rays. Okay, reflected rays will come only after there are incident rays. Correct or not, students? And for the incident rays means there should be object. And here it's a real object. So for every real object, there will be a virtual image. For every real object, there will be a virtual image. And now here similarly, these are reflected rays. How can we say these are reflected rays? See the direction of arrows. Okay, they are going away from the mirror. Now, for this reflected rays, first of all, there should be incident rays. Okay, these are called as incident rays. Okay. Now, these incident rays, when you extend them like this, they'll meet at one point. This is called as virtual object. This is called as virtual object. So, see, so for a virtual object, there will be a real image. And for a real object, there will be a virtual image. Okay, students. So always remember here, I'll write down. Here I'll write down it as, okay, for every virtual object, there will be a real image. There will be a real image. And for every real object, there will be a virtual image. There will be a virtual image. For every real object, there will be a virtual image. Okay. And for every virtual object, there will be real image. And for every real object, there will be a virtual image. So these terms you should know thoroughly, students. These are very, very important terms. Okay. And I hope you know, I hope you learn these definitions thoroughly. Okay. So tomorrow I'll ask first 5 to 10 minutes randomly. I'll ask these definitions: what is meant by real object, what is meant by virtual object, what is meant by real image, what is meant by virtual image, and all. Okay. So please first write down these terms, understand these terms, learn these terms, and then tomorrow when I ask, please say it honestly. Okay, because it's online. Okay. So therefore, these definitions are very, very important. Don't take it lightly, students. In fact, to solve problems in optics, you should know these terms thoroughly. These terms should be known thoroughly, students. Okay, because in optics we have very few formulas. Okay, like mirror formula 1 by f equal to 1 by u plus 1 by v, or lens formula 1 by f equal to 1 by v minus 1 by u, where in those formulas u is called as object distance, v is called as image distance. So to know whether that to substitute those terms, there is a sign convention, and that sign convention is entirely dependent on this whether the object is real or virtual, or image is real or virtual. Okay. So for everything there is a sign convention. So first of all, if you identify which type of object is it or which type of image is it, then only you can assign sign convention, and then only you can substitute in those formulas, and then you can get the answer. Okay, students. So these are very, very fundamental definitions. Okay, you should know it thoroughly. Okay, and these definitions will be valid for all the topics. That means reflection, refraction, whether it is planes, whether it is in reflection at plane surface, or refraction at plane surface, or reflection at spherical surface, or refraction at spherical surface. Okay, students. So please learn it thoroughly. Okay, once for all. So this is for today's class. Today I discussed, I think, up to here. And as I told you, I've given 2 homeworks. Homework number 1 is to study these 4 definitions thoroughly. And homework number 2 is I'll give some questions from the first year topics. Okay. So that you'll not forget the first year topics also. So today's topic is rectilinear motion, vector, and mathematical tools. So I have given 8 questions. So these are the first 4 questions. And next one is 5, 6, 7. And next one is 8 questions. These are the 8 questions. Okay, students. So please solve these 8 questions. Okay, in the afternoon time, you have time, plenty of time. So please do this homework number 2. Okay. First question, you know, this is from kinematics. Okay, vectors. This is also kinematics, and then this is what we call differentiation and integration. Okay. And then this one is basic vectors or kinematics. This is also kinematics, and kinematics 7th question. Eighth question is also kinematics. Okay, students. So I hope you'll study the definitions and solve these questions. Okay. If you want, you can send me the answers in my WhatsApp, or otherwise just solve. I'll send the answers also. Okay, students. So, but please solve it. So keep a separate homework notes, and please solve in this in that homework notes all these questions. Daily, I'll be giving some 10 to 15 questions from the first year topics, and as we progress further in optics chapter, I'll also give questions from these optics also. I'll include both first year and second year topics. Okay, students, because finally at the end of the year you should write for mains, okay, or NEET. Okay, so therefore you should start preparing from now onwards both first year topics as well as second year topics. Very, very important. Okay, so therefore that's why I'm giving simultaneously first year topics questions also, so that revision will also happen simultaneously. So please don't neglect solving these questions. These are very, very important. Okay, if you are not able to solve these questions, at least solve H.C. Verma or D.C. Pandey, whichever book you have. Okay, and revise these chapters, kinematics, vectors, and all. Okay, or any other chapter which you like. Okay, but if you are able to solve, it's well and good. If you are not able to solve, take H.C. Verma or D.C. Pandey or any other book and then solve questions. Okay, every day half an hour you should solve. Okay, I recommend every day you should spend half an hour for revising the class notes and 1 hour for solving the problems. So that means every day 1.5 hours you should, apart from the teaching class. Okay, I am teaching for 1 hour in the morning, 7 to 8. So apart from it, you should spend 1.5 hours. Okay, half an hour for revising the notes, formulas, and another 1 hour for solving the problems. So this is very, very important. So please go through all these, go through the chapters. Okay, first year chapters, revise those chapters. Don't forget those chapters. Have formula sheets. Okay, and for second year, since today is the beginning, at least from today onwards, write down the formula sheets of second year, because second year topics, as we are completing means both, it's like integrated. We are covering intermediate, mains, advanced, everything will be covering. Mostly mains, little bit advanced, and intermediate is already covered, will be already covered. Okay, means only few questions will be there, and then few derivations will be there that I'll explain at the end of each chapter. So please go through it. Okay, students. So that's all for today, and from tomorrow onwards I'll record and send it and post it in the app. Okay. Thank you very much, students.